In this video, we will study how to find the Laplace transform of a periodic function. A periodic function is a function that repeats itself at a period nt. This is the equation of a periodic function. For example, the square wave shown here is a periodic function which repeats itself at time 2t. To find the Laplace transform of a periodic function, we find the Laplace of one cycle, which is represented by f1s, and then to find the final Laplace, we multiply it by 1 by 1 minus e raised to minus st, where t is the repeating period. So let's do few problems based on this. Let's first find the Laplace transform of this set of pulses which repeats itself at a time period capital T. Up to t by 2, the amplitude is A, and from t by 2 to t, the amplitude is 0. So let's find the Laplace transform of the signal for one cycle, and in t domain the signal is represented like this. So this is the unit step signal u of t. This is the unit step signal that starts at t equal to a. Let's equate this to 0, so you get t is equal to a. So this signal basically starts from this particular point. Now we subtract this signal from this, we get this particular portion which is our signal, and the equation of that is u of t minus u of t minus a. So in our question, a will be nothing but the time period which is t by 2. So we have to find the Laplace transform of one period which is this signal. So this is f1 of t which we have just found out. So if we take the Laplace transform, u of t becomes 1 by t and u of t minus t by 2 is shifting property. Therefore it becomes e raised to minus t by 2 s by s. So we have to multiply a periodic function by 1 by 1 minus e raised to minus st, where t is equal to t by 2. So split this term into 2. The numerator and denominator term gets cancelled and we finally get this answer. Suppose if you are asked to find the Laplace transform of a Sawtooth waveform as shown here. It is a periodic function, so let's find the equation for one cycle. The period given is p and the amplitude is k. We know that for a line with slope, the equation is y is equal to mx plus c, where y and x represents the respective axis and m is the slope and c is the intercept. To find the slope, we use the equation m is equal to y2 minus y1 divided by x2 minus x1. So y2 is this point which is k minus this point which is y1, that is 0, and x2 is this point p minus x1 which is this point 0. So substituting these values, we get the slope m is equal to k by p. Now substitute for m in this equation, so we get f of t is equal to k by p into t plus 0, where 0 is the intercept or where it intercepts the axis. F of t is y and x is t, the respective axis. So we get the equation of the line is equal to k by p into t, where k is the amplitude and p is the period. Now we have to find the Laplace transform of this one particular cycle, and by substituting this function over here, by integrating and applying the limits, we get the answer like this. Next, to find the Laplace transform of a periodic function, we multiply it with 1 by 1 minus e raised to minus st, where t is the period. So here it is t. So we get this answer.